Hey guys, this is Mr. Bennett and this is video 8-3. You'll notice that things are a little bit different. I'm not using PowerPoint this time around. I'm actually using something that looks exactly like the notes that you're writing on. Let me know what you think. I'm just trying a different way of doing things, so to speak. So the first thing I want to do is take a look at some review problems here. So this is an idea that I think many of you are kind of confused on, and that is what's a molecule and what's a salt. So a molecule is a covalent compound, which means that you have a nonmetal bonded to a nonmetal. A salt, on the other hand, is ionic, so it's an ionic compound. Okay, which means you could have a couple different options. You could have a metal bonded to a nonmetal. You could have something with a polyatomic, or you could have essentially just a cation bonded to an anion. Okay, those are all kind of different ways of describing how you make an ionic compound. So salt is a general term that is used for ionic compounds. I know that the salt that you think of is sodium chloride, but salt is a general term for anything that's an ionic compound. Just like molecule is a generic term for anything that has covalent bonds holding it together. So let's take a look at these examples here. It says circle the molecules, underline the salts. So here, the first thing that I see is I have a metal. Second thing I see is I have a polyatomic. So right off the bat, as soon as I see that polyatomic and the metal just kind of confirms it, this is an ionic compound, which means it's a salt, which means I underline it. Okay. Second guy here, I have a carbon bonded to hydrogens. These are both nonmetals, which means nonmetal, covalent. It's a molecule, so I circle it. Now this one's a little tricky. Manganese is a metal, zinc is also a metal, so actually I don't do either one. I don't circle it, I don't underline it. This is actually a metallic. Okay, so we leave it alone. Moving on. Here we have phosphorus and bromine. These are both nonmetals. Nonmetal means covalent. It's a molecule, so we circle it. Okay. Now we get to chromate. Okay, chromate bonded to chlorine, 4 chlorines, which are nonmetals. So chromate's a metal, chlorine's a nonmetal. Metal nonmetal means ionic, salt, so we underline. And then last but not least, we have an oxygen bonded to another oxygen. That means nonmetal, covalent, molecule, circle. Okay, so you just need to get to the point where you understand that molecule and covalent compound are interchangeable. Okay, and then salt and ionic compound are interchangeable terms. All right. The other review idea I want to go over real quick is the idea that ionic bonds are formed by transferring electrons, whereas covalent bonds are formed by sharing. What does that really mean? Okay, explain the difference. So with an ionic compound, you have 2 atoms, right? Or an ionic bond, right? And what happens is one atom essentially gives or transfers its electron to the other one. The atom that lost its electron now has a positive charge. The atom that gained an electron now has a negative charge. Okay. Once you have those opposite charges, you then have your electrostatic force that pulls them together and they stick. Okay, that's ionic. Now covalent, okay, they share. So with sharing, what happens is you have an atom with an electron, you have another atom with an electron, right? They're both short of having an octet. So what they decide is, hey, we're going to share. So these electrons will now travel back and forth between these 2 atoms. Both atoms get to use the electrons, and as they travel back and forth and they're shared, it makes them more stable, getting them closer to the octets. Okay, so the electron over here actually moved over here, stays over here. That's how we get the charges, and then they stick together. Here, it's actually the electrons traveling back and forth between the 2, being shared, that keep these 2 atoms close together. Okay, all right. So let's talk about new stuff. So the new stuff that we're focusing on with these notes is what do these molecules, because we're talking about covalent compounds, what do these molecules actually look like? So we want to look at the shapes that are predicted. Okay, and to do that we use something called VSEPR theory. So VSEPR is an acronym. What it stands for is valence, shell. So what this means is the electrons in the outer shell. Okay, the outer part of the atom, so those valence electrons. And then EPR stands for electron pair repulsion. Okay, so what does that really mean in English? It means that the electron pairs repel each other, so they will be as far apart as they can. Easy enough, okay? Electrons are negatively charged, a negative next to a negative, they repel, they push away, okay? So what it really comes down to is that there are 4 shapes you need to know, 4 three-dimensional shapes that you need to know and be able to spot. So if you figure out the Lewis structure or the structural formula for a substance, for a molecule, you need to tell me which shape it is, okay? So the first shape you need to know is linear, okay? And there's really 2 ways that you can get linear. 2 options for getting linear. The first way is you can just have 2 atoms. Okay, 2 atoms bonded. In other words, if I have an atom and another atom and I bond them together, the only shape they can form is a straight line. Okay? The second way you can do this is if you have 3 atoms bonded together. Okay? So in other words, you have a central atom with 2 things attached. Okay? And no unshared electrons on the center. What happens, what turns out is that the central atom in any molecular shape, okay, the central atom will create a lot of the 3-dimensional shape, meaning a lot of what's going on with that central atom determines what the shape is. So when you make these, when you draw your pictures of the molecules, you want to look at that central atom and see what's going on, because that's really going to determine a lot about the shape. So here we have 3 atoms bonded together, and notice there are no unshared pairs. When we look at this carbon here, nothing, right? No unshared pairs on that carbon, so it's going to have a linear shape. Now let's move on to our second shape. Our second shape is called tetrahedral. First thing off the bat you should notice is this prefix tetra, which means 4. Hedral means faces, so faces are, I think, heads as well. Could also be another interpretation. But the idea is that you have a central atom with 4 things bonded to it. Okay, and there's really only one way you can get this. Okay, you have a central atom, a center. Okay, by center I mean central atom, plus 4 atoms bonded, and notice there are no unshared. Okay, no unshared electrons on the central carbon, right? All electrons are being shared with the other atoms. So you get this nice, cool, like four-sided thing. Okay, moving on, last 2 shapes. The third shape, kind of fittingly, is what we call trigonal pyramidal. Similar to tetrahedral. Okay, notice that the base of this kind of looks the same. The difference is this right here. Okay, what we've done is we've gotten rid of that top atom that would have been bonded there, and instead we have an unshared pair. And it turns out the reason why unshared pairs are so important to the shape of the atom is that they're responsible for repulsion. They repel things. So if we look at this example over here, we have nitrogen. It's bonded to 3 hydrogens, and it has an unshared pair on top here. These unshared electrons are pushing down, causing what would have been flat to bend downwards and form kind of a, whoops, make that go away. Go away. Give me 1 second. We'll make that go away. There we go. Okay. So anyways, those electrons are pushing down, okay, causing it to get that nice kind of pyramid shape. Okay, and there's really only one way you can get a trigonal pyramidal, and that is you have a center plus 3 atoms bonded. And unshared electrons, right? You have to have those unshareds because that's what creates that pyramidal shape. They repel, they push down on the others. Okay, so that's the third one, trigonal pyramidal. And then the fourth and final shape is what we call bent. It's similar to linear. So notice we have 3 atoms here, but the difference is the central atom has unshared pairs. So the way you get this is you have a center plus 2 atoms bonded and unshared electrons. Okay, so if you look at here, we have this oxygen, right? Oxygen and 2 hydrogens. So think of it as like an oxygen with hydrogen and a hydrogen. But that oxygen has unshared electrons. So those unshared electrons are going to cause repulsion. They're going to push down on those hydrogens, which is going to actually move them so that they're down here instead. Okay, so they'll no longer be up here anymore. They get repelled and pushed down, which creates the bent shape. Okay, so those are the 4 shapes. So now let's see what it looks like when we actually have to predict what these things look like.